Hello, this is Mr. Wynn, and today's lesson will be about logarithms and logarithmic functions, and this is very important. So, the definition of a logarithm is b to the p power equals n. So, a base to power p equals n, a number. That's the same as p equals log base b of n. So, the power equals the logarithm of base b of a number n. All right. That left side is called exponential form because you have an exponent. Basically, p is the exponent power. At the right side is called logarithmic form because you have the word log in there. Now notice you have no exponent on the right side. So what logs do is they get rid of exponents and bring them down. But you can go backwards and forwards. So basically, exponents get rid of logs. Alright, now note, all logarithms have bases. So whenever you see the word log, there has to be something down here next to it before you the number. So it could be number 10, it could be number 500, 3. All right, so log of a base and then number. So example 1, change the following from exponential form, because I have exponents, into logarithmic form, meaning we need the word log. And then we check in the calculator. Why start with some simple examples that y'all know are true. 7 squared equals 49, because y'all know 7 times 7 equals 49. I'm just trying to show you that the definition of logarithm is true. So what I'm going to do is I'm going to label everything. So b equals 7. All right, that's our base. P equals 2. And n equals 49. So if I use those and plug into the formula, it says p equals, so p is first, 2 equals log with the base, our base is 7, and n is 49. That's my answer. So I'm going to show that is true by checking the calculator. In the calculator, you're going to press math. You're going to go up to A. It says log base. Press that. So there's the base. Put that number 7 down there. And inside it says 49. If I click enter, you'll see it says 2. So 2 equals log base 7 of 49. Standing for the bottom, 4 cubed is 64. Well, b, the base is 4, p, the power exponent is 3, and the number or answer is 64. Filling in the formula again, it says p equals, so 3 equals log, the base is 4, and the number is 64. So I'll check that in the calculator. So math, go up to log base. Base is 4, the number inside is 64, that gives me 3. Alright, so we know that formula is true. You can also go backwards, change from logarithmic form to exponential form. So basically we're going to switch back and forth a lot. So same thing, we're going to label all the letters. Well, we know that 2 right there is the base. So b equals 2. That 8 is the n. And p equals 3. So plugging that entire equation, or the formula is b to the p equals n. So b is 2 to the p power equals n. And that we know is true. 2 cubed is 8. You only check the calculator, but 2 times 2 times 2, of course, is 8. Same for the bottom. We're going to label b, p, and n. So b is 5, n is 25, and p is 2. Now by follow the formula, b first. So b to the p power equals n. Y'all know 5 squared is 25. Right, so if you memorize that formula, that's fine because you need to switch back and forth a lot. However, I do not actually use that formula. I don't memorize it. I have my own trick that my teacher showed me. So basically, you figure out what you're trying to get rid of. You're trying to either get rid of exponents or logs. All right, you're trying to get rid of exponents. You're going to bring them down into the front by log basing both sides. What I mean by this is you have 7 squared, the exponent 2. I'm trying to get rid of that. So I want to get rid of the exponent. I'm going to log base both sides. I'm going to log both sides by base 7. All right, so no matter what you do to one side, you do to the other side. All right, so that's what I did. Now, once you do that, you're allowed to move the exponent in front. And also, I need to tell you all this. There's a very important fact. if you log base the same number, you cancel out to 0. So for example, log base 2 of 2 is 1, log base 10 of 10 is 1, log base 500 of 500 is 1, log base b of b is 1, log base x of x is 1. And I can use that in calculator fast. So for example, math, go up to this, log base 2 of 2, oops, I didn't put 2, log base 2 of 2 equals 1. Log base 10 of 10 equals 1. Log base 500 of 500 equals 1. So you see how when I take the log of both sides, I'm strategically picking it to make sure that this cancels out to 1. So all I have left is 2 equals log base 7 of 49. Notice that's the same answer we got right here. 2 equals log base 7 of 49. If you memorize this trick, or not memorize, just are able to do my trick, it'll make it a lot easier for you to solve problems later on. Because right now we're just checking to show you that the equation is true. We're going to start solving it later on. All right, same for the second part. Going backwards. So instead of trying to get rid of the exponents, what if I'm trying to get rid of the word log? Right, you get rid of the word log by exponentiating both sides. Because logs and exponents are opposites, like adding, subtracting, multiplying, dividing, square powering, and square rooting. They cancel each other out. So I'm going to turn both sides to exponents and use the correct base, which always matches the base of the log. What that means here is, see I have the word log base 2 of 8. I'm trying to get that log 2 out of the way by making both sides exponents and putting 2 at the bottom. This will make this cancel out and just leaves the 8 by itself. And the other side is 2 to the third power, because y'all know 8 equals 2 cubed. Same answer as before. Right here. It's backwards, but same thing. 2 cubed equals 8. Here I have 2 cubed equals 8. Right, this follows from this nice fact. If you have a number raised to the log of the same base power, they cancel each other out, and you simply get the number inside the log. So if I do 2 to the math log base 2 of, say, 10, I get the answer 10. If I do 10 to the log base 10 of 5, I get 5. And by the next one, you'll see that the 25 and log 25 cancel out. So this cancels, I just get 10 as my answer. These cancel, I get 5 as my answer. These cancel, I get 73 as my answer. These cancel, I get n as my answer. I guess I should have gotten back to, no, they did. All right, so if you know my tricks, you're good. It's the same thing as using the formula. There's no difference, but I don't memorize where b, p, n in the word log go. Right, so it helps you for doing this. Solve for y in this equation. Well, I see the word log. I'm going to get rid of it by exponentiating both sides. There's no exponents here. So my correct base would be 16. That cancels. All I have left is 4 on the left side equals 16 to the y. Now from the previous video, y'all remember, same bases means same exponents. So for now, I'm going to rewrite that 16 as 4 squared, because that's 16. Y. Y'all know power to the power. So 4 to the first power equals 4 to the 2y. They're the same base. 4s, they're the same exponents. So 1 equals 2y. And if I solve for y, I divide both sides by 2. I get y equals 1/2. And that's it. Alright, so remember your exponent rules. I'll teach you something a little easier later on, but this is what we're doing for now. Now technically, if you have log of a base and a number, you can type in calculator. So let me go to the math, log base 16, and the number inside is 4. That gives me 0.5, but as a fraction, that is 1/2. So really, we didn't have to solve by hand. All right, a log graph looks like this. It's that b, the base, is basically like our factor, our rate. If it's bigger than 1, it's growth, like this left side, so it's going up. And if it's, so here, b is bigger than 1, it's growth going up. If b is between 0 and 1, it's decay, it's going down. There's the domain range, no extrema, no symmetry. There is an asymptote, and that's the x-axis, meaning x equals 0. Basically, it can't cross the left side. So here's the very important note. You can never, ever, ever take the log of 0 or a negative number. And I can even show you that right now. Say I try to take the log of 0. It says error domain. Say I try to take the log of negative 10. It says non-real answer, imaginary. Alright, so cannot take the log of a negative number 0. What else? It follows this format where A, H, and K do the same thing that they always do. Taller or up, down, left, right, taller, wider, flipped or not. It's not going to bother too much about that. Inverse. So last thing is this. Remember, inverse means flip x and y, and then solve for the new y. So if I rewrite that, that's really x equals 10 to the y minus 1. Well, what we're trying to do, you could use the definition logarithm, or I know I'm trying to bring that exponent down. I want to get that y minus 1 down so I can solve for it like normal. That means I'm going to log both sides. So with the y minus 1 down, I'm going to log base 10 both sides. Alright, so this cancels, and base that y minus 1 comes down. And this is just log base 10 of x. Now, I want to solve for the y, I got to move this 1, so I have to add it to both sides. Right, now, be careful. This left side is log base 10 of x. X is right inside. That 1 is outside. It's not inside the logarithm. Right, equals y. Or maybe I'll just put the y on the left. That's my answer. All right. So logarithms and exponential functions are inverses. You use the other to get each other. All right. Here's your practice problem. Change the following to logarithm form into exponential form. Follow the formula or do my trick. Either log both sides or exponentiate both sides. There's your answer. If you knew that, you should be fine for class. Again, this is a very important lesson. Make sure you understand it. If you have questions, ask. And thanks for watching. This is Mr. Wynn. See you in class. Bye.